Alright, hello and welcome to the programming lecture. This week we're going to talk about loops, which you already know. We're just going to do them in Python now. And then lists, which is a new thing. So I guess let's get right into it. But first, a short break into a topic called errors. So this is when things go wrong in a program, what kinds of errors can you get? So there are two main kinds in Python, and they have two separate classes. So runtime errors and logic errors. So let's talk about runtime errors first. The word run is key here, so maybe I should make that in bold. The idea with runtime errors is it's an error that happens as your program executes. And the key is that it's an unrecoverable error. Because it's unrecoverable, that means the program gets stopped whenever a runtime error occurs. It can't go on. It cannot recover from whatever horrible thing happened. So the most common runtime error, the one that I guess probably makes the most sense to you right now, would maybe be a division by zero error. And so let me show that to you in idle. So I'll make a new file. Let's maybe call it runtime error. There's many different kinds of runtime errors, but this is one. Runtime error example.py. So maybe we can just be like, we can do some stuff. We can say print hello world. Oops. And we can just continue doing normal things like x equals 1, print x, and then eventually we do something silly like print, I don't know, x divided by 0. Okay? It's at this point where a runtime error will occur. So the program will execute a little bit. A little bit of the program will get executed. So we'll see two things that get printed out. But as we try to calculate the value that we need to print for this third print statement, that's when the runtime error happens. And so, without further ado, we run this, and we print hello world, set x equal to 1, print x, so we print 1. And then finally, we try to do this, but it doesn't happen. So it tells you all the bad things that happened in red, and it tries to show you where it went wrong. It's like, okay, on this line, something happened, and it tells you, oh, it was called a zero division error in Python. It's like a variable. It's one long word to Python. That's the name of the error that occurred. It's a runtime error. It's called a zero division error. And here's a text description of that. So you try to divide by 0. That was a bad idea. Okay, so that's a runtime error in a nutshell. Now a logic error is a lot more subtle. Oops. A logic error is also called a bug. And we've had many a bug in Scratch, but let me give an example of a logic error in Python. We're intending to do one thing, but actually doing another. So here's the simplest logic error that I can come up with. Make a new file, call it logic error. Oh man, it's always trying to save in the weird folder. Logic error example. And for this one, maybe I'll be like, hey user, give me a number. And I'll use input to do that, and then I'll set n to be an int, of course, because right now it's a string whenever I get it back. So I'm going to change it into an int. And okay, I'll print back to the user, your number plus 2 is colon space, and then after, I guess I don't need the space, then after a comma I can put that number plus 2, but I'm going to type n plus 1. Ooh. Well, the program's going to run. We'll run to completion here, but it will not do the right thing. We found a bug. We have a bug. We tell the user, hey, I'm about to print your number plus 2, but we print it only plus 1. So that's the simplest bug or logic error that I can think of. Okay. So with that, let me get into the meat of today. Now we know how things can go wrong. Let's give ourselves some more ways to do things weird by having some more programming constructs. So a list, I'm going to draw in a few ways, but the idea of a list is I have a bunch of information. I have a bunch of numbers, and I care about their order, like 42, then 43, then 17, then 18, then negative 27, in that order. It's a special order to me. For some reason, I want it to stay like that. I want to keep these numbers right next to one another. Okay? That's the idea. So a list is something in Python that holds a bunch of stuff in a single variable. So the order matters, and the syntax for that is you use some brackets. So here's the list 1, 2, 3. So in English, we'll say that that is the list 1, 2, 3. And the order is important. 1 is the first thing. I'm sorry I'm having to spell this out, but it's important. 1 is the first thing. 2 is the second thing, and so on. So the order is important. Technically, you can put multiple things of different types, but usually you keep everything of one type. That is essentially a list in a nutshell, and it's a one single thing as far as Python is concerned. Which means I can set a list equal to a variable. All right, that means I can say, all right, well, here's my favorite variable name, x. I'm going to have it hold the list 1, 2, 3. I can do that. I can have x hold more than one number. That's interesting. Okay, what's x? Print it out. Okay, it's that list. What's the type of x? Oh, it's a list. That's helpful. But wait, what if I wanted the 1? What if I wanted the 2? What if I wanted the 3? There's more than meets the eye here. Okay, using lists. So you can make lists pretty easily. So that's the 1, 2, 3. You can make lists in order, or you can make lists from scratch. The empty list looks like this. 2 brackets. There's nothing in it, but it's a thing. It's an empty list. There we go. These characters are right next to each other, but I don't like how it makes that tiny little box. Okay. Well, that's interesting. Oops, that was some starter code for later. So I can say 1, 2, 3. I can say, okay, that's a list of a certain length. This is a list of a smaller length. It's a list with just 1 in it. Here is an empty list. Ooh. It might be useful to know how big a list is then. Oops. Oh no. Well, let's undo all of that. If I think it will be happy now. If L is a list, it's a variable that holds a list, then len L gives you the size of that list. That's useful. So you can see, all right, if L equals 1, 2, then print size of L will print out to the screen the number 2. Okay? Or we can use the REPL to do that same effect. Say, all right, what's the... Oh, sorry. I can't think and write at the same time. It's len L. So I can say, what's the len of x? And it's still this one up here. It's 1, 2, 3. So its answer is 3. What's the length of 1, 2? Well, it's 2. Length of empty list, 0. Okay, that's all. That all makes sense. Cool. This is not enough. So here's my list L. It's got 2 things in it. 1 and then 2. If I print L, I get the whole silly list printed out to me. That's not really useful if I want the pieces. Okay, so I can say print x. That gives me 1, 2, 3, or I can say print the length of x, and that prints me the 3. But what if I just want the 2? Like, what if I want the thing that's right there in the second, what we call index? So now we need a little bit more terminology, and we're almost masters of lists. Okay, so indexing into a list is the next thing. So let's set x. Let's have x be a list. 1, 2, 3. And now in memory, I'll draw it like this. This is what x looks like. It's one big variable, but it's got 3 things inside of it. It's a list with 3 things. 1, 2, 3 in that order. So you can access each individual element of a Python list, and the way you do that is through indices. Okay? And the key thing is, the weird thing is, this will become very, very common, and you'll get very used to it, so it won't seem weird. But right now it might be weird, is that indices start at 0 in computer science. So if you want the first element of the list x, you have to get the 0th index. Okay? And so that means if you want the second thing, you need to access the 1th index. We'll say. Because it's not really second anymore. It's not really first anymore, if that makes sense. So really, secretly, inside these lists, there's little numbers associated with them in the order that they are. So 1 has index 0. 2, that element, 2 has index 1. 3 has index 2. Okay? And the way you access indices is through, weirdly enough, the same brackets. So if you want the first thing of x, so accessing x's index, x at index I, let's say, in Python looks like the following. You say x and a brace, or a bracket, or whatever you want to say, x of I, x at index I, okay? So it's almost like you're using the list syntax all over again, which is weird. So here we go. Maybe I should make a new file now, just to put all this stuff in one place. Call it lists. Lists.py, and it will always try and save in the wrong spot. Dun dun dun, there. Okay, so lists, let's make our favorite list. X equals 1, 2, 3. X is a list of size 3. Then we can print the length of X. And I guess length and size, therefore, are synonyms. If I run this, it's going to print 3. If I print X, it's going to print the whole list. And if I want a certain index, I have to use that notation. So this is going to be hard to get used to, but X of 0, X at index 0 is the first thing. X at index 2 is the second thing. Yeah. Or sorry, 1, then 2. This is the second thing, and this is the third thing. So it's kind of off by 1 in your mind, and you will eventually get used to this. So X of 2 is the last thing. It goes 0, 1, 2. Those are the indices of this. And we can reset them as well. We can say, all right, X of 0, I'm going to make that 42. So I say print X now. It'll print the whole list, and oh man, did I change the first thing, the 0th thing, to be 42. Okay, that's kind of cool. Okay, what else? The indices also go backwards. The last element can be index -1, you can say. Dot, dot, dot. So if I put underneath, alternatively, maybe in red or something, who knows, this has index -1. This also has index -2. This also has index -3. So you could use either one to get to it. It just depends on your point of view, okay? Which one's the right one for your problem. So each index has 2, so each location. Okay, and I'll prove that to you. Print X, -1, -2, -3. Okay, so -1 gets the last thing. -2, gets the second to last thing. And -3 gets the third to last thing, which in our case, because it's a short list, is the first thing. Okay? So that is lists in a nutshell. All right, moving on. You're now professionals. Loops is something you already know how to do. Okay, so I'm just trying to get you up to speed with Python's loops now. So just like in Scratch, a loop repeats a certain amount of code. And it can be repeated forever, or it could be repeated for a certain amount of time. Okay? You can make a forever loop, you can make, okay, this needs to iterate 10 times, that's all. So remember the idea of a loop. It's you have code that you want to continue executing for as long as a certain condition holds, usually. So you have some kind of condition, then you have a bunch of code that you want to keep running. You want a way to get back to yourself so long as something is true. And so let me talk to you about the first kind of loop in Python. let me make it a bit more concrete first, though. So in Python, the standard kind of loop is called the while loop. Okay? And what it means is, a while loop executes a piece of code. We call it its body, just like for if statements, as long as a condition, and again, just like an if statement, is true. And we're in Python, so it's capital T for true. Okay? So a while loop executes its body as long as a condition is true. So the idea is we have some kind of condition. Let's call it C, and it evaluates to either true or false. And if it's true, we're going to run the body, which could be many lines of code. Okay, this is the body. And after that, we're going to keep on rechecking our condition. Eventually, it'll become false, at which point we're done with the loop. This is like the rest of the code. Okay, so let's talk about while loops specifically now. Let's talk about the syntax. So the idea is just like if statements, very, very similar. Actually, it's almost exactly similar, but the key difference is that the body can be re-executed. Okay? So this is what it looks like. You say while, and then you give your Boolean expression, which I've been calling BEXP, and then some colons, and then you tab over, as usual, and then you give your code. So this is body line 1, and you stay tabbed over as long as you want to be in the body. This is body line 2, ... And then finally, you stop the indentation, and your program continues. This is just normal code after this. Outside the loop. So that, in a nutshell, is a while loop, and I'm going to give you plenty of examples, don't worry, but this is what it looks like. So you pick a Boolean expression, and as long as that Boolean expression is true, it's going to execute the entirety of your body. Okay? So that's why we call it a while loop. So while BEXP is true, execute the body, and then go back to recheck exp, and repeat. Go back to the beginning. That is recheck BEXP. Eventually, your condition, your Boolean expression, will become false. And after that happens, you're done with the loop. Okay? So the simplest loop that I can show you is let's have a forever loop in Python. How do you think I might do that? Take a second, maybe pause the video and think about how you might make a forever loop in Python. You just got to make this bexp never false. So it'll always continue the body. It'll never finish the loop. Well, I know a Boolean expression that's never false. Dun dun dun. Call this while, or forever loop. Forever while loop. How about that? I know. While true. True is never false. So this body will always be repeated. The loop will never stop. So what are we going to print? I don't know. Hi, Mom. So it's just going to print hi mom until the end of time. And this is our forever loop. Okay? While true is a forever loop. And so we will never get down here. This line will never be executed. So this is outside of the loop, but we've just said that this loop never finishes. It'll only finish when the condition becomes false, and we made sure it's never going to be false. So here it goes, printing hi mom forever until the end of time. The way to stop your program is to press Control-C. That'll stop a runaway program. Okay? Okay, a program with an infinite loop. We say, okay, that's a forever loop. Let's do something a bit fancier. Let's, I don't know, let's sum the numbers from 1 to 10. Or actually, let's do that, but also let's print the numbers from 1 to 10 first. In that order. Okay. Let's print the numbers from 1 to 10. And I'm not ready for turtles yet. Here we go. I guess I don't need to keep these open. This is like while example. While examples.py, let's say it. So the idea for this, printing the numbers from 1 to 10 in order, is going to require a variable. So I'm going to keep track of a variable, and because I'm doing this thing called iteration, I'm trying a bunch of possibilities. That's what iteration means, right? I'm going to save a variable that I'll start at 1, and we tend to use I as programmers, to I for iteration. I'm going to start I at 1, and I'm going to keep on printing I as long as it's less than or equal to 10. Okay? So this should scream while less than or I is less than or equal to 10 to you. Do you see that? And then I'll just always remember to add 1 to I as well, to change it between 1, then 2, then 3, then all the way to 10. So if that made no sense, the code probably will. So let me give that to you. So I equals 1. So start I at 1. And then we're going to say while I is less than or equal to 10, so as long as this is true, I being less than or equal to 10, we're going to print I. Okay? And then we're also going to increment I. I equals I plus 1. And then after the loop, maybe I'll say done, because after it's finished, we need to know that it's finished. All right, so the reason this works is I starts out being 1, and then as long as it's less than or equal to 10, so right now it's not, or right now, yes, it is less than or equal to 10, it's just 1, it will print I, make I 2, and then come right back to the condition. We always keep coming right back after we execute the body until the condition becomes false. So here we are. I is less than or equal to 10. Now it's I is 2. We'll print I again, increment it to 3, and we'll come back to check the loop. Eventually, we're going to keep on doing this until we print 10, make I equal to 11, and then we're going to stop the loop. Okay? So if we print I has to be 11 here. That's the only way the loop stopped. So here's how it works, or here is it working in order. 1, 2, 3, all the way to 10. Then we print done after the loop finishes, because I becomes 11. This is now false. it's greater than 10, print done, then print I to prove that because the loop stopped, this has to be false, and the way that we incremented I means it has to be 11. Okay, I hope that makes sense. That's printing the numbers from 1 to 10 in order. How do you think you might do it in reverse, just quickly? Yeah. Well, how about you start I at 10? I'm just going to print a bunch of, print some spacing, maybe. Let's do the same thing, essentially. This time we're going to start I at 10, get rid of that. While I is greater than or equal to 1, we'll print I, and then we'll subtract 1 from it. So it'll become 10. Print the 10, make it 9. And as long as it's greater than 1, we're going to keep on going. 10, 9, 8, 7, 6, all the way to 1. Print 1. Now I is going to be 0, and this is now false. I is less than 1. Okay, I hope this is making sense. Please yell at me in office hours if it's not. So now it's going in reverse order. Okay? So now let's do the original thing. Let's sum the numbers from 1 to 10. Okay, let's sum the numbers from 1 to 10. And let's see here. So again, I'll make some space. The idea here, like I did in Scratch, is we're going to have a variable that keeps track of what number 1 we're on, with I again, and we'll also need a sum variable. So I will start at 1 again, and sum, because we're going to keep adding into sum, it needs to start out as 0. Okay, so we'll add the 1 into sum, make it 1. Then we'll make I 2, add the 2 into sum, make it 3, add 1 to I, make it 3, add 3 into sum, make it 6, all the way down until I is 10, we add it in, and then we have a final answer in our sum variable. Okay? So there's a lot more moving parts now, but hopefully it's still making some sense. So I equals 1, sum equals 0. Ooh, sum is a keyword in Python. I don't know if this is okay. Maybe I'll call it... Let's see if it's okay for now. We'll say while, again, we want I to go between 1 and 10, so while I is less than or equal to 10. I'm going to keep on doing this stuff. But instead of printing I, we're going to add I into sum. So whatever I is right now, it's going to go between 1 and it's going all the way to 10. Add it into sum. Sum equals sum plus I. Then we'll say, okay, I equals I plus 1. And then finally, sum has the correct answer once the loop stops. It will have the sum from 1 to 10 because we started adding 1, then 2, then 3 into sum all the way through 10. Okay? And sum from 1 to 10 is, and then we'll say sum. Boop. And oh man, is it 55. And I didn't need this space. When you put a comma, it actually puts a space for you, and I always forget that. There it is, 55. Very nice. So, that's some examples of while loops, and I think I'm going to have to skip for loops this time. We'll have that in next lecture, because I have to get through an extended example. You can iterate through a list with loops, with while loops. So, let's say x equals 1, 2, 3, 4, 5. The valid starting index of x of any non-empty list is always 0. So the first index. This is always true. And the last index of x is, well, it's 0, 1, 2, 3, 4. How can we figure that out no matter the list? It's len x minus 1. Do you see that? That's key. That's always the last index. Okay? So if we want to make a variable that goes between all the valid indices, we can start at 0 and stop as long as we're less than or equal to len minus 1 or less than len, strictly. Okay? So let's print out a list with a while loop. I'll make a new file. Doesn't matter what the list is, we'll print it. So x is 1, 2, 3, 4, 5. We will go through all the valid indices of x. So we'll say, all right, the first index that we can go through is 0. So while I is less than len of x, that's the usual way to do it, or less than or equal to len minus 1, do stuff. These are the valid indices. That's the range that we want I to go between so that we can access x of I and have it be something normal. X of 0 is 1, x of 1 is 2, x of 4 is 5. That's super nice. Okay? We can say print x of I. Okay? So this is going to print everything in order, and this is very powerful. Oh, oops. I have an infinite loop right now because I have a bug. I have a logic error. It's going to keep on printing 1 forever because I never changed I away from index 0. Shame on me. I equals I plus 1. And now it'll print 1, 2, 3, 4, 5. Don't forget, like I did, to advance I. Okay. So now, in the last few minutes, I want to give a fun example of Python. So I'm going to try and see if I can open the stuff from last time. I'm going to save it in this file, I think. I want to print not just 5 squares like I did last time. I want to print 50. 50 squares of random sizes and random colors. This is going to be fun. Okay, so let me open this from last time. This is lectures, random squares. I'm going to copy and paste all of this. And what I'll do is, I kept on copying and pasting this code. I only need it once because I can use a loop now. Boop. And so now we can loop 50 times. So I equals 1 while I is less than or equal to 50. Please draw a square in a random spot. So I'll just tab over. And so now this is going to happen 50 times because I is going to change. Assuming we advance I always. So this is going to draw 50 random squares, and I'm going to make the turtle's speed a bit faster by commenting this out. I'm going to have it be the default speed. Oops, the color, I don't know. Right now, let's make it pink. Is this a thing? Boop. So we're drawing random squares, but they're all pink. That's no fun. Or maybe you like pink, who knows. Let's stop this. Control C, X. I want to pick the color randomly. Screw what the user wants. I'm going to make a list of colors. Here's all the possible colors. Red, orange, yellow, green, blue, purple. And I'm going to choose a random color each time. I'm going to set the fill color to be color to choose of a certain index, but I'm going to make it be a random index. Okay? What's a valid random index? Well, it's any number between 0 and this length minus 1. Oh man, random.randint 0, len colors to choose, minus 1. So this will pick a random index into this list, and it'll get out a random color because of that. I really encourage you to play around with this. This is really cool, I think. And so now, we're going to get, I guess we only have rainbow colors, we're going to get 50 squares with random colors because we're going to loop 50 times. We're going to make sure of that with I. I goes between 1 and 50. And we essentially copied the code from before, but we made sure to advance I, always. And the reason we're getting random colors is because we made a list of all the colors we want to choose from, and we picked a random one each time we start this loop. Pick a random color. We set the fill color like that. So the reason we get a random one again is because we only have indices 0 through 1, 2, 3, 4, 5, which is the length of this minus 1. And a random number between those will give me every possible index, and it'll choose one from those. So add a random index, go there in my colors to choose list, and pick a random color. That's how we pick a random color, by picking a random index. Okay, we set the fill color, and it looks like it's finished now. It's drawn 50 random boxes, and of course we rerun the program. Because of randomness, it's always different. You'll never, well, maybe in a million years you'll get different squares each time. But that is where I want to leave you in terms of examples. I'm going to break for just a second so that I can set up your programming assignment, and then I'll come right back, explain that to you, and then that'll be that. Okay. Alright, so we have learned how to draw fancy things, and you'll be using that for your programming assignment. I'll give you 2 weeks to do this, give you a little bit of a break. This one shouldn't be too bad. You're basically going to take the code that I wrote today and the code that you wrote in your last assignment and kind of combine them. So here is what I want you to do. I want you to write a program that does the following things. Okay, so I want you to ask the user for a number. And in my example down here, when I explain, I'll call it n, but you can call it whatever you want, x or I or whatever. So n is the number of shapes that the user is asking us to draw. And so each time it'll change. So I want you to do the following steps n times, as many times as the user asked us to do. 0 is valid, I guess. N times, using a while loop, I want you to set the color to a random one. And you can do what I did. You can use more colors too, add them to your list. These are all the colors that the turtle knows about. You can use all of these little names, put them in the string, and it will make these colors for you. Okay, so you can add all of them if you really wanted to. Have a fun little, very filled in rainbow of different shapes. And okay, then I want you to randomly pick to draw a square or a triangle. So this program is going to have squares and triangles being drawn. So you get to pick inside of this loop. When you're about to draw the next shape, you need to pick whether or not it's a square or a triangle, and I want you to do that randomly. One way to do that is to pick a random number, 1 or 2, I guess. And 1 means square, 2 means triangle, maybe. So that's up to you. But play around with that. That should be fun. So you get to draw squares and triangles this time. And then again, pick a random size, and then draw that square/triangle with the randomly chosen color, with the randomly chosen size at a randomly chosen location like you've been doing. So in essence, you're drawing n shapes, squares or triangles in total, with random colors and random sizes and random locations. Okay? You should be able to reuse a lot of my stuff, and as well as your stuff. So that's all. I'll give you 2 weeks to do it. Turn in a little bit before Halloween, and yeah, as usual, I think the turtle might go slowly, so maybe I'll have to increase this time, but whatever you'll be reading is the correct version. So I'll leave you there. And yeah, I think that's all I've got for you. Have fun with this, and I will see you in the next lecture.